All right, lesson 8.6, solving rational equations. So we're just going to have fractions on one side, fractions on the other. Some x's in the denominator. What do you do? Well, a couple ways you can do it. You can do it. You can multiply every term by the common denominator, and that clears out your denominators. Or you could find a common denominator, like we've been doing the last three days here, and write each expression over that denominator. So like on example 1, the common denominator would be 2x. The term on the left would need a 2, so that'd be 6 over 2x, then it's minus. The half would need an x, so it's x over 2x. And the 12 over x would need a 2. Okay. Well, when you do that, you can basically say the denominators don't matter. Like if I told you to do 2/3 plus 5/3, well, you should say that equals 7/3. And from that, you're basically saying 2 plus 5 equals 7. The 3's don't matter. It's all about the numerator. So that's all we got going here. 6 minus x equals 24. And we're solving that. Subtract the 6 and divide by -1. So 24 minus 6 is 18. Divided by -1 is -18. Now, be aware that you have to think about the restrictions. X in this one couldn't be 0, so if I got an answer of 0, I'd say, oh, no, that doesn't work. And there'd be no solution. Okay, so I'm just going to go with the make a common denominator and then drop it theory here. I've got x plus 1 as a denominator for 2 of them, and the other denominator is 1. So in example 2, I can make them all something over x plus 1. And to do that, I would need to take the 4 and multiply it by x plus 1. So I'd end up with 4x plus 4. Denominators can go away. They don't mean anything because they're the same. Bring over the 4x. I get x on this side. Put the 4 minus 5 together. I get -1 on that side. And you're going, oh, looks like -1. Wait a minute. In my restrictions, x couldn't be -1. So actually, no solution. Okay, moving on to the next page. Two more problems here. Example 3. Find a common denominator. To do that, you might want to factor. Factoring x squared minus 4 turns into x plus 2x minus 2. And then I got 1 over 1. Which means the common denominator looks like it would be x plus 2, x minus 2. So this one needs an x plus 2. The 6 is good. This one needs both. And then I just need to evaluate the numerators. So, you could write that denominator 3 different times, but I don't know, we're all pretty smart. Just go, you know what, those denominators aren't going to matter. It's all about the numerator. So let's multiply the top left. FOIL that out, you get 3x squared plus 6x minus 2 is plus 4x minus 4. On the right, we have 6. And then our x plus 2 times x minus 2 is x squared minus 4. That's quadratic. We solve quadratics by making it equal 0. And then we can do quadratic formula or hopefully factoring. So, well, first off, let's change 6 minus 4 into just 2. So I've got x squared plus 2 on the right because 6 minus 4 was 2. So I'm going to minus over the x squared. 3x squared minus x squared is 2x squared. I'm going to minus the 2. And there's my quadratic, 2x squared plus 4x minus 6. I'm going to try to factor that. I'm going to take out 2. And then can anything multiply to equal -3 and add up to 2? Well, certainly. I could go positive 3 and -1. 3 plus -1 is 2. 3 times -1 is -3. So my answers appear to be -3 and 1. 3 and 1. Make sure it does not create complications with your original problem. Make sure that it's non-restrictions. Restrictions look like they'd be -2 and 2, because if I plug in a -2 here, I get 0. If I plug in a 2 here, I get 0. So I didn't get -2, I didn't get 2, so these are good. Example 4. Well, sometimes on example 4, ones like this, it's simplest to just cross multiply and go top times bottom equals bottom times top. But that's not one of these cases, because if I did that, I'd end up with an x cubed term right here. 2x squared times x is at 2x cubed. And then I'd have to look at grouping to solve, or maybe it's synthetic division to solve. So for this one, because it's factorable in the denominator, I would say factor the left. We go to 2x. And then say, all right, what's the common denominator? Well, pretty simple to make a common denominator. Take the right side times 2x, and you would have 2x times x plus 1. So ignoring the denominators, because they don't matter. They're the same, so they don't matter. I can just say 6 equals 2x squared minus 4x. And that goes to 2x squared minus 4x. Subtract over the 6 equals 0. And that should look pretty familiar. It's almost identical to what we just did in the previous problem. You just get the opposite factors. So possible answers are 3 and -1. But if you go back here, you see, oh, if I plug in -1, I get 0 right there. So that's not a possible answer. That's in my restrictions. So that doesn't work. So the answer is 3. So there's 4 fairly simple examples of solving rational equations. Thanks for watching. Have a great day.